Okay, so I wanted to do just one example to show you what do we do if we get an integral that we want to use u substitution on. Okay, so like 3x minus 1 to the 5th dx with limits. So what if it was from 0 to 1? Okay, so technically I could do this one without u substitution if I wanted to FOIL out 3x minus 1 5 times, which I don't. All right, so I'm going to forget about those limits for a minute. I'm going to come over to my scratch work here, and I'm going to figure out the antiderivative of 3x minus 1 to the 5th with u substitution. Okay, so I would let u equal the inside function, and then du would be 3 dx. All right, and then I would say, okay, here's my u. And then for my du, I need 3 dx. So I'm going to squeeze a 3 in there and compensate with a 1/3 on the outside. So that over here, I get my du. So I get 1/3 integral u to the 5th du. Then the 1/3 goes along for the ride, and I get u to the 6th over 6. Normally we put a plus c, but this integral really we know over on the left has limits, so I'm going to forget about the plus c. We don't do that for definite integrals. So I either get u to the 6 over 18, or if I do my substitution again, let's see, u is equal to 3x minus 1 to the 6th over 18. Okay, so I'm going to save my scratch work over here. Okay, so this is the first, there's 2 ways to deal with those limits. And the first way is to just figure out what the integral is equal to. Okay, 3x minus 1 to the 6th over 6, over 18. And then evaluate that from 0 to 1. And just plug in like you normally would. So I'm going to plug in x equals 1. And plug in 0. And evaluate. Okay, so this is 2 to the 6th over 18 minus negative 1 to the 6th over 18. Let's see, 2 to the 6th, 32, 64? 64. Negative 1 to the 6th is going to be positive 1. And I get 63 over 18. Okay. All right, so really all I did was substitution and then add on the extra step of plugging in the limits, and that is a perfectly good way to do this problem. And if that makes you happy, then you can stop the video and never have to think about option number 2. Option number 2, all right, is to do your u substitution, and so we get 0 to 1, 3x minus 1 to the 5th dx. And we rewrote with our u substitution 1/3 integral u to the 5th du. At this point, if you would like, you can also switch your limits. Okay, so the 0 and the 1, you can convert those to u values. Okay, so I had done this u substitution with u equals 3x minus 1. Okay, so I can say when x is equal to 0, u is equal to 2. And when x is equal to 1, my top limit wait, that was negative 1, sorry. Negative 1. Negative 1, and this one is 2. Yep. Okay, so the integral from when it was x dx was from 0 to 1, and now when it's du, I can rewrite my limits as going from, instead of x equals 0 to x equals 1, u equals negative 1 to u equals 2. And what this allows you to do is to never have to switch back to x's at the end of the problem. Okay, so just like in my scratch work, I would evaluate here, but instead of having to plug in the 3x minus 1, I can just evaluate from -1 to 2. Okay, so I would get u to the 6th over 18, and we still end up doing the same arithmetic, 64 over 18 minus +1 over 18 to get 63 over 18. All right, and some people love this method and they're like, this is the best thing ever because I don't have to switch back to x's. I just have my limits as u's. They're very easy to plug in. And some people hate that, think it's a waste of time, and we should just switch back to x's and go on as we usually do. So whichever one you like better, you are welcome to do. You always get the same answer. Okay.